Okay, we got a lot to learn in this lesson. I'm going to review some division rules and tactics and then show you how it applies to polynomials. Okay, so recall when we have a normal division, we have one number on top of another, and by normal I just mean there's no variables, and we want to simplify it. So what's our first step for simplifying, or whenever we have a fraction, is we want to cancel out the factors they have in common. And for a quick example, if we had 6 over 12, they both have a 6 in common. 6 divided by 6 is 1. 12 divided by 6 is 2. We get 1/2, right? So we simplify. And we do that based on what we know the factors to be. So in the case of 6 and 12, we can break it down in the long way. We can say 6 is 2 times 3. 12 is 2 times 2 times 3. And we just cancel everything we have in common. Boop, 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 boop. We're left with, and when there's nothing, it's a 1. We're left with 1 over 2. Okay, so same thing for all other numbers as well. So, and we're going to break it out the long way. We're going to break everything into factors now so that you get used to it when we're dealing with the polynomials as well. So we got 30 times 45. So we want to break it into the factors. And if you need to do factor trees, do factor trees. In fact, I'm going to do a factor tree for you here, even though I know what it is. So 30, we want to break it down into its factors. That's a 3 times a 10. 3 is done. That's a 2 times a 5. Done. All right, so we know the factors of the 30 are going to be broken down as a 2 times a 3 times a 5. And for 45, we know it's 5 times something. 5 times 9. 5 is done. 9 is 3 times 3. 3, 3. So we know that the 45 is 3 times 3 times 5. And now we can cancel everything we have in common. We're just left with 2 over 3. Okay, simplified. That's all we're doing when we're dividing. We're simplifying because we don't care about mixed fractions. We just want things as fractions or improper fractions. We don't want remainders and crap. All right, let's do 120 and 72. This one is going to be a little bit bigger, I believe. 12 times 10. 12 is, we just did that for the lesson below. That's going to be 2. I'll work it out. I'll do the long stuff. Always do it the long way so it prevents mistakes. All right, 120 is going to be 2 times 2 times 2 times 3 times 5, and then 72. We know that it's even 2 times something, 36. 36 is 6 times 6. And then we got a 2, 3, and a 2, 3. So we got a 2 times 2 times 2 times 3 times 3. Cancel, 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 cancel. We're left with 5 over 3. Perfect. You know that. Okay. Here we're going to look at another principle of division in fractions. I don't know if you've known this before, but I'll try to make it as much. I'll teach you right now. So, let's say we have 1/2 plus 1/2. No, that's not what I want. 1/3. No, that's not what I want. This is what I want. I want 1/4 plus 2/4. So if we added those together, of course we would get 3/4. And I'm just going to manipulate it a little bit. So we know that 3 is the same as 1 plus 2, so we could just break this down to say 1 plus 2 over 4. And if we wanted to, we can see that, all these things are equal, right? We're just adding here. We just broke this 3 apart here, right? They're just different ways of writing the same thing. Obviously, we usually just work with the simplified case because that makes the most sense. But if all these things are the same, it shows us that when we have the numerator broken up, remember the numerator is the top half of the fraction, it shows us that we can actually split it into fractions around by the terms. So we can split this up into 1 over 4 plus 2 over 4, okay? So it's just showing us how we can move fractions around. So we can either have it completely simplified, we can have it as two fractions, or we can have it as a split numerator, okay? And if we see this, if we see, oh, 1 plus 2 over 4, that's the same as 1 over 4 plus 2 over 4, okay? Normally there's no reason for us to do that. With polynomials, sometimes there is. So let's recall our previous fraction, 30 over 45. Now, if we so wanted to, 30, we can split that up into different numbers being added together. So 30 is actually the same as 3 plus 12 plus 15, right? All those things add up to 30. And so that's how I ended up with this thing over to the left, where I have 3 plus 12 plus 15. Now, if we also wanted to, we could just split it apart even further. Like we said previously, we can split this into three different fractions. We can have 3 over 45 plus 12 over 45 plus 15 over 45. So 3 over 45, 12 over 45, 15 over 45. Now, you don't necessarily need to know how to split it up like this. Just follow with me for now and just soak in what I'm doing. So it's just showing you, you'll see. Okay, so now we have three fractions, okay? So remember before when we wanted to simplify a fraction, we just find the common factors and simplify it, okay? So let's look at each of these individually. What would it take for 3 over 45? Let's simplify that as its own fraction. So 3 can go into each of them. 3 goes into 3 once, 3 goes into 45 15 times, okay? So this first fraction simplifies to 1 over 15, all right? We're just simplifying them individually. Now, okay, so let's just look at the next fraction. 12 and 45, they're not even. They both have a 3 in common as well. 12 divided by 3 is 4. 45 divided by 3 is 15 again. So we got 4 over 15. And then over here, we've got 3 can go into each of them. 5, 15. If we wanted to, we could do one more, but I'm going to hold off for just a second, just for the sake of our example. So we simplified it. We simplified our three fractions. We simplified them, and we showed that it's the same as 1 over 15 plus 4 over 15 plus 5 over 15. If we add all these up like normal, we would get 10 over 15, which simplifies to 5 goes into each of them. 5 goes into 10 twice. 5 goes into 15 three times, which simplifies to 2 over 3, which is what we got before for 3 over 45, 2 over 3, so we know we did it right. Now, obviously, it came out to the same answer. I'm just showing you there's different ways of thinking about it, where even if we split up our number into separate parts and simplified them separately and added them, we're still getting the same result. Okay, let's take a look at this one over here. Like I said, this was, we started with our 120 over 72. We broke our 120 into 24 plus 36 plus 60. And now we can break these into three separate fractions. So that's going to be 24 over 72 plus 36 over 72 plus 60 over 72. Now let's simplify each of these fractions separately. 12 goes into 24 twice. 12 goes into 72 6 times, I believe. And like previously, I'm not going to simplify it all the way just for the sake of our example. 12 goes into 36 3 times. 12 goes into 72 6 times. And then lastly, 12 goes into 65 times. 12 goes into 72 6 times. 2 plus 3 plus 6 gives us 10 over 6. 2 goes into each of these, so we get 5 over 3. And that's what we got previously right here as well. So we know we did it right. Okay, so it just goes to show you that really the point was we can break up a fraction like this. We can break it up by term. Okay, so we have 3 terms here because they're separated by pluses and minuses, which means we can break it up into 3 fractions. That's really the point. That's what I want you to take away. You can turn numerators that are broken up into a polynomial into separate fractions and simplify them separately. Now, let's see how we do this with polynomials. Okay, so now it's time to merge our concepts together. So we're no longer dealing with just numbers, we're dealing with numbers and variables. And we have this polynomial being divided by this monomial. Now, a couple ways we can think about it. As we remember previously, when we're dividing across a whole polynomial, it's kind of like distributing the negative, as in we divide each term separately, okay? But it's also just going to be easier for our writing purposes to do what we did on this slide right here, which is just break it down into 3 separate fractions. So that's what we're going to do. So when we see something big and complicated and it tells us to simplify, we're just going to break it down into easier to manage chunks. And this is question 2 on page 204. So let's break it up into chunks. So this is the same as 16x to the power of 4 divided by 2x plus 8x cubed over 2x minus 12x squared over 2x. And look, just like all the other times, the plus minus follows, it sticks with the thing it's associated with. Anyway, all right, so now we want to simplify each term, and to do that, we factor it. So I'm going to break it down into all the parts like we did right here, so we can learn from this. So this is a good time to show you how we use our factor tree for using variables too. So let's first break it up. So remember, factor trees are what 2 things multiply together give us what we have. So right here we have 16x to the power of 4. So first let's break it up into 16 times x to the power of 4. 16 is the same as 4 times 4, which is 2 times 2, and 2 times 2. X to the power of 4 is the same as x to the power of 2 times x to the power of 2, which breaks down into x and x, okay? So that's the same as 2 times 2 times 2 times 2 times 4 times 4, or times x times x times x times x over 2x, okay? And so we, 2 times x. So we cancel everything in common, a 2 and a 2, an x and an x, and what we're left with is 2 times 2 times 2, which is 8, times x to the power of 3, because it's being multiplied by itself 3 times. Now, the other way of thinking about this, just look at the number parts. We got 16 divided by 2, which is 8. And for here, we got 4 x's on the top, 1 x on the bottom. It's just a subtraction problem. 4 minus 1 gives us 3, okay? So this is the long way if you need to think it out all the way. But if you can think about it in parts, do division here, and just subtract the exponents here. Okay, so now we go to the next one. 8 divided by 2, or how many times does 2 go into 2? Once. How many times does 2 go into 8? 4 times. Okay, so we can do that. And now let's look at the x's. We have 1 x in the bottom, 3 on the top. 3 minus 1 gives us 2 right here. So we can just cancel out our exponent and change it. So this is just 1 in the bottom, which means we can just rewrite what we have on the top, which is 4x squared. And this should be an x cubed right there. And now we go to the last term. 2 goes into 12 6 times. 2 goes into 2 once. 2x is on top, 1 in the bottom, which means we have 1x left, which means our last term is going to be a negative 6x because of the negative right here. Okay? So look, we took this big old chunk and we turned it into this polynomial right here. Okay, this one is question 4 on page 204. And once again, we're just going to break it apart into two different fractions. So this is the same as 81a squared over negative 3a. And here we have minus, because of our minus sign right here, minus 9a over negative 3a. Okay, so let's do this. Let's do our, how many times does 3 go into 81? 27 times. 3 goes into 3 once, okay? And then there's two a's on top, one on the bottom. 2 minus 1 gives us 1a left over. So that means we have 27a, but keep in mind we do still have this negative. We don't want to lose track of our negatives, so that's a negative 27a. And then we go over here. We have 3 goes into 3 once, 3 goes into 9 3 times, and then we have an a on the top and the bottom, which means they just cancel. And we also have two negatives, which we can cancel out right now, which means we're left with a positive 3. Okay? And then lastly, let's do this one. Looks all complicated and hard, but all we got to do is break it up into the parts. 7a to the power of 4, b squared over negative 7ab minus, because of our minus here, 14a5b cubed over negative 7ab plus 21ab and negative 7ab. And as a reminder, your first step is to always just rewrite what you have on your piece of paper. Now, let's do our cancellations. 7 goes into 7 once, 7 goes into 7 once. We have 4 a's on top, 1 on the bottom. 4 minus 1 means we have 3 left over. We have 2 b's on top, 1 on the bottom. 2 minus 1 means we have 1 b left over. Our first term is going to be, what is it? A to the power of 3 times b. And don't forget, we do have our negative right here that did not get canceled, so it's negative a3 b. And then let's go to the next term. 7 goes into 7 once, 7 goes into 14 twice. We got 5 a's on top, 1 on the bottom. 5 minus 1 means we have 4 left. This one on the bottom cancels. 3 b's on top, 1 on the bottom, which means we have 2 left on top. And then our negatives can actually cancel, which means our next term is going to be positive 2a to the power of 4, b to the power of 2. And then lastly, we have 7 goes into 7 once, 7 goes into 21 3 times. Both a's cancel, both b's cancel, and we do have our negative that does not cancel, so we have a negative 3. And so this divided by this gives us this polynomial right here. So they look complicated and confusing, but as long as you take your time and work it out, you'll be fine.